Our next talk is by Bob McCoy on ultraviolet remote sensing for the DoD, a legacy of Charles Barth. And your minds will be erased afterwards.
Okay, I was a student of Charles Barth, late 70s, I graduated in 81. And as everybody knows, Charles Barth knows what a passionate guy he was. And a lot of his passion rubbed off on me, and I want to talk about that, how it shaped my career. And I think you'll see fingerprints of Charles Barth all over my career. Four things in particular. Being a student, I had to study nitric oxide. It was required. And odd nitrogen photochemistry, that's a given. And I acquired that passion. Ultraviolet remote sensing, it's a very powerful tool, especially limb scanning ultraviolet remote sensing. I did a lot of that. Low cost access to space, low cost satellites. And then finally, for my dissertation, they gave me a sounding rocket. And as a couple of you have already mentioned, that ruined you. Anybody who did a sounding rocket, the rest of your career, you're ruined. So these four things have carried me through my career. The last, I left, when I was here at LASP, I was in the Army. I went to ROTC at Cornell, and I owed the Army 4 years. So when I left here, the last 6 months, and Karen remembers this, I was using FTS lines to find a job. And it took me 6 months, but I found a job at the Naval Research Lab. And the idea was to find a job where I could do what I was trained to do, because I had all this passion. So I went off to work in the Army for the Navy, and trying to do ultraviolet remote sensing and nitric oxide. And I had some success with nitric oxide, but for the most part, the Department of Defense, they didn't want to hear about it. Once or twice, I was able to sneak things in, as I'll show you. But one thing the military was interested in was the ionosphere. You can see it here in this chart, because the ionosphere affects navigation and communication and even satellite altimetry. So I spent most of my career trying to convince the DoD that using ultraviolet limb scanning spectroscopy, you could see the ionosphere. It wasn't easy because, and this shows you, this is a composite spectrum of the Earth's air glow, showing that across the ultraviolet, you can see how powerful it is. Everything shows up there, all the major ions and molecules. And there was a way to measure the night side ionosphere. It was pretty well done. But you didn't have a day side capability. Until we could show that, nobody was interested. So analyzing some Berkeley data, looking at 834 angstroms, or 83 nanometers, I found a way to do that, looking at scanning, spinning, scanning, looking at the limb. So once we do that, the doors started to open, and money started to flow. So the first thing we did, working with Aerospace Corporation, and this was in a post-SME days, we tried to build a platform that would measure everything across the spectrum. Each part of the spectrum requires a dedicated instrument, so we put together 8 instruments looking across the whole wavelength range from 500 to 8,700 angstroms. 3 Ebert-Fasty spectrometers, you hear that a lot, and some imaging spectrographs. One of them was one that George Mount, who was here, had designed, an imaging Wadsworth on the instrument. And then several other LASP people helped us. Jim Pranke, Dave Cleary, Scott Bailey, and Don Anderson all had been here at LASP. I put Don in blue because he's a theoretician. So anyway, so we built LASP. We got a ride for it on NOAA 14 weather satellite. NOAA launched number 13 and lost it. It was an operator error. They blew up the satellite. The satellite went dead. So they kicked us off. This is around 1990. And it took me a while to find a ride for it. In fact, it took 19 years to find a ride for it. And I went through 9 different opportunities, and I always said yes. And something always happened. That's another whole story. But eventually we got a ride to the space station out of Japan, out of Tanegashima, Japan. It took us about 7 days to get there. RAGE is there today. It's still working. It stopped scanning about a year or so ago, the scan mechanism of 12-volt power supply failed. But all 8 instruments looking from 500 to 8,700 angstroms are still working. And you can see that astronauts can actually look out the window and see RAGE sitting out there. And a lot of videos, RAGE pops up because it's pretty sitting out there. In the meantime, the follow-on to RAGE is going to be a high-resolution version of this. So we built the high-res experiment. There we were going after a half angstrom resolution down in the EUV. We also had Dave Cleary's Isaac instrument. Dave Cleary was another. Isaac was, again, nitric oxide, focusing on that part of the spectrum. That flew and was a success way before RAGE. But then we convinced the DoD that, hey, this works. This is a way to do this. In the meantime, Paul Feldman and I had each had a rocket, sounding rocket to look at Comet Halley. And as you heard today, Charles Barth had an experiment on the shuttle, on the Challenger, which went down. So Paul and I went to NASA and said, hey, nobody's going to be there when Giotto flies by. Let's refly our rockets. And so NASA agreed to that. This is an image at Lyman Alpha of Comet Halley taken in the reflight. It's actually a spectacular image. It was on the cover of Avweek and Nature. And again, there's a connection to Charles Barth. This is all to scale, and the sun in this little circle here to the left, that's 2 million kilometers. So this is the diameter as viewed from the rocket of Comet Halley at Lyman Alpha, looking at atomic hydrogen. So in the meantime, we convinced the DoD that this is the way to go. We had a day-night capability. We had proved it with some sounding rocket flights. And so they funded us at NRL to build 5 of these. We actually built 6. 5 of them in orbit, 1 more is going to launch. It's an EUV Wadsworth. It's limb scanning, just like everything else we did. 800 angstroms to get the 834 out to 1,700 angstroms. Like I said, one of them first was launched on a LASP Delta II, a LASP Titan II, and then ultimately on larger rockets. In the meantime, working at ONR, I was able to fund at Bob Schunk to build an assimilation model for the ionosphere. So we had some place for this data to go. So it just doesn't go on the floor. So the last 4 years of my career, before I retired from the Navy after 30 years, I was detailed to operate the Operation and Responsive Space Office in Albuquerque. I was the tech director. Congress wanted to bring down the cost of access to space. So I was working at ONR. I had my own program there called Tactical Space, Innovative Naval Prototypes. I had $80 million and I built 8 payloads, and they're all in space, they're all in orbit. And at ORS, we were building buses and rockets and things like that. So we launched all these things. One of them was the RAIDS payload to the International Space Station, along with the hyperspectral sensor. Most of the 80 million went into TACSAT-4, a big communication satellite, launched out of Kodiak. We launched out of Kodiak in September of 2011. I raced back to Albuquerque, drove all my stuff back to DC, retired, and went back to Alaska. And then showed up in the middle of October at the Geophysical Institute. And that's where I've been ever since my second career. You see a sounding rocket? It took me 2 years to get that rocket out there. Field lever speaker helped me. Most of it's NASA funded, but some of it's rear tank and welding. We had to be a little creative there, but it's out there. And if you come visit, you'll see that rocket, as long as it also with other things. So just to talk a little bit about the GI and what we do in my new career. There's about 400 of us in the Institute. Alaska is a very geophysically interesting place. We've got 52 active volcanoes. Last year we counted 40,000 earthquakes. We've got 100,000 glaciers that are disappearing fast. We do a lot of weather observations, a lot of satellite remote sensing and unmanned aircraft. And finally, where I got started doing space physics and astronomy, we do a lot of operational things. We monitor volcanoes, we count earthquakes, and we monitor them. It's nice to be a student in Alaska in the GI. In the summer, you're out in helicopters. We have a couple classes. One is Learn to Return, and the second is Bear Safety. And we issue shotguns. We issue shotguns to our grad students so they don't get eaten by bears. It's a great place to downlink data. We have the Alaska Satellite Facility. Polar orbiting satellites whiz overhead, 11 out of 14 orbits. Phil mentioned the Poker Flat Research Range, where we launch we help NASA launch satellites. We have an infrasound center, which we created last week. We have a Center for Unmanned Aircraft, which we're also teaming with Oregon State and several others. I was in the Senate yesterday for a ceremony. We got a new Center of Excellence. We have a supercomputer. We do a lot of mapping. Just a couple of rocket things, just to. Phil mentioned there were 4 rockets launched this past winter. He wasn't there, or he would have said it was 30 below zero. But they were all successful. We had two of our faculty launch rockets this year. This is a composite photograph. I think Phil showed some of this, showing there were 2 TMA releases. That was actually Miguel Larson from Clemson, and Richard Collins from the GI launched these rockets. There's Aurora in the background, but it actually wasn't about Aurora. And if you look carefully, you can see things like, in this photograph, you can see things like, there's a LiDAR. Rich Collins was making LiDAR measurements in the upper atmosphere, around 90 kilometers, looking for inversions. And you can see things like this, where the actual first stage impacts. This was the TMA release that Phil showed. I was actually out there at 30 below zero taking these photographs. You can see the LiDAR facilities. this looks kind of weird, this TMA cloud. And somebody sent me this composite photograph. I know it can't be right because Miguel is from Clemson, and why would he put UAF? Anyway, I asked Kathy Rich, the director of or the manager of our range, for pictures of Charlie Barth had been there several times launching rockets. And these are a bunch of slides he sent me a couple weeks ago, and we get them digitized. And it's too bad that Charles won't be coming anymore. But Scott Bailey has a launch this coming winter, so we'll have him there. And as you heard today, he'll actually be launching a payload that Charles Barth built. So, in summary, I hope you can see his fingerprint, all of this stuff, these things that I talked about, and being influenced on my life and my career. And I'm still doing this stuff, still launching rockets, and still having a good time. So, thanks.
Questions for Bob? I have a question. So now that you're not at the Navy anymore, have all the opportunities for small, interesting science instruments gone away?
Mostly.
Yeah.
Unfortunately. It was hard to keep pushing. Once you stop pushing, it's easy just to, so.
Okay, let's.
I guess after the last two talks, I should have someone do an inventory of all the Ebert Fasties that have flown either in Earth orbit or in the solar system. I missed a messenger one in my list this morning. I thought it was a Cassini design, but it was not.
And should add to that the Pioneer Venus Design Verification Unit and Flight Unit that Ian Stewart gave me. That was my dissertation rocket. I flew 2 Eberts at White Sands.
Yeah.
So.
Oh, there were lots of Eberts on sounding rockets, but I was just thinking of orbiting satellites.
Orbit.
You mean Fasties, though, right?
Yeah, Eberts with the thumbprint.
Good. Thanks, Bob, again.